Hello, welcome back. Patrick this is here. So this is the fourth part of the Learn iOS 7 SDK tutorial. So today we are going to subclass UIView and UIScrollView. So in the previous videos, we've created several views, UI button, UI label, etc. But what exactly is a view? A view is an instance of UIView or one of its subclasses. A view knows how to draw itself on the application windows, on the applications window, an instance of UI window. A view knows how to draw itself on the application window, an instance on UI window. Sorry, I repeat this sentence. A view exists within a hierarchy of views. The root of this hierarchy is the applications window, and a view handles events like touches. So in this video we are going to create our own UIView subclass that fills the screen with concentric circles. We are also going to learn how to draw text and enable scrolling and zooming. So let's create an empty application. We are going to call it Hypnosister. And the class prefix is going to be the same. And click next. And create. So the view make up by the user Views make up by the user interface of an application. Each view maintains an image that represents it. For example, a UI button's image was a rounded rectangle with a title in the center, but now it's a little different. A UI label image is just text. When something about a view changes, like UI label's text property or UI button's title, the view image is redrawn so these changes become visible on the screen. Another subclass of UI view is UI window. Every application has exactly one instance of UI window that serves as the container for all the views in the application. The window is created when the application launches. So you can see here, so application did finish launching with options, this. So the template code creates UI window and they make it visible. This puts the window on the screen, and once Windows is on the screen, you can add other views to it. So when a view is added to a window, it is said to be subview of the window. Views that are subviews of the window can also have subviews, and the result is a hierarchy of view objects. A view will appear on the screen if and only if it's been added to this hierarchy, either directly as a subview or the window or as a subview of another view that has been added to the window. And the window is the root of the view hierarchy. When the screen is redrawn, the window's image is drawn to the screen. Then all the subviews of the window draw their images to the screen. Then the subviews of the subviews draw their images, and so on. So creating a user interface boils down to this. Create each view image and add each view to the view hierarchy. Classes like UI button, mkmap view, and UI text field already know what their images look like. Sometimes, however, you want to create views that draw something not supplied by Apple. In this case, you need to create a custom view object and write code to create the image. So now we are going to create a new file. it's going to be Objective-C class, and how can we call it? Hypnosis View, and it's going to be subclass of NS object. Click next. Let's target on Hypnosister, and in the header change this to UIView. So now we have UIView subclass. So let's create an instance of Hypnosis View and set its background color property from UIView and add the Hypnosis View to the view hierarchy. Open the delegate now, and at the top of this file we need to import Hypnosis View header, and we need to locate this method and create an instance of Hypnosis View and add it as subview of window. So here we need to create rectangle view frame. It's going to be equal to CG rectangle make 160, 240, 100 and 150. And we need to create an instance of Hypnosis View. It's going to be called view equal to Hypnosis View. This, initialize it, frame, view frame, view, set background color. Here we are going to set background color. I'm not going to tell you anything that we are doing here actually. UI view, UI color, sorry, red color, and self window, add subview view. And there are some brackets, too much. And let's run this application and see what is going to happen. I'm not going to say anything. Wait until this loads. And also this is going to be a little long part or episode or however you want to say. I'm sorry, I don't know why this isn't. So it's loading. It takes some time. And you see, here it is the red rectangle. So now let's explain it. So here we create an instance of view. Here we set background color. So we create first frame, and this is the frame, and this is this frame, like border or however. Then we create an instance of this class with this frame, and then we set the background color to red of this class or instance of this class, and then we add it to the view, to the window. And that's easy. So yeah, so let's create another instance of Hypnosis View. First we can make like a little easier. Hypnosis view, another view is equal to hypnosis view this, initialize with frame correct make, we can make 20, 30, 50 and 50. And we need to another view, set background color, UI color, blue color. And we need to add it to a window. Self window, add subview of another view. So let's do this again. So here it is, the another instance that is, that has a background color of blue. And we can, so a view hierarchy can be deeper than 2 levels in Hypnosis. In Hypnosis or AppDelegate M, we can insert another view as subclass of view. So, not this, but we need to create view, add subview of another view. This would be even better. So let's run this application again. So notice that even though another view's frame did not change, its position on the screen did. A view's frame is relative to its superview, not the window, so the top left corner of another view is now in set 20, 30 points from the top left corner of the view. And that's it. So till now we created the UIView subclass, created 2 instances of it and inserted them into the view hierarchy. We gave these 2 views instances distinguishable and background colors so that we can see their position and size on the screen. But views comprise all iOS interfaces. So clearly there must be a way to draw more than just colored rectangles. The drawing that makes a view interesting happens in the UIView method drawRect. By default, drawRect does nothing, but UIView subclasses override this method to perform custom drawing. When you override drawRect, you issues drawing instructions that create the image for instances of your UIView subclass. These drawing instructions come from the core graphic framework, which is automatically added to an application's target when you create a new project. Let's override drawRect in Hypnosis View. The first thing that we need to do in drawRect is grab a pointer to a drawing context. A drawing context maintains the state of drawing, like the current drawing color and thickness of the pen, and performs drawing operations. A drawing operation draws shapes using the current drawing state. At the end of drawRect method, the image produced by the context becomes that view image. Before view is sent the message drawRect, a drawing context is automatically created and set as the current context. In Hypnosis View main or M, enter the following code to grab a pointer so that context in drawRect is like this. So let's create. It's going to be type of void what did I did? So wait, draw rect. So CG context ref CTX is equal to UI graphic get current context. So type CG context ref is defined as CG context, a pointer to a CG context. CG context is a structure that represents a drawing context. The suffix ref makes it easy to distinguish between pointers to C structures and pointers to Objective-C objects. Here, CTX points to the current drawing context. A view's image is the same size as it appears on the screen, the same size as the view's frame. The frame describes the view size relative to the view's superview. However, the view shouldn't have to know about its superview until it gets to compositing its image to the screen. So there is a separate CGRect property of UIView named bounds that gives the view its size independent of its superview. In Hypnosis View.m, get the bounds rectangle in URect after you get pointer to the drawing context. So let's create another URect bounds is equal to self bounds. The drawing operations you perform on the CG context ref must fall within the bounds rectangle. Otherwise, they will be clipped to that rectangle. Let's draw a circle in the center of the bounds rectangle. Add the following code to drawRect that I'm going to write there right now. CG point center dot x is equal to bounds dot origin dot x plus bounds dot size dot width slash 2.0, and let's copy this. So y and this height. And we need to create float max radius is equal to HIPOT bounds dot size width bounds size height slash 4.0 semicolon. CG context set line width CTX 10. Then CG context set stroke color CTX 0.6 0.6 0.6 1.0 and CG context add arc, and this is not set RGB stroke color, right, and CTX center dot X center dot Y radius max radius start angle 0.0 end angle MPI multiplied by 2.0 and clockwise, yes, and CG context stroke path CTX. And so let's run these applications. So now there are the same rectangles drawn, but with circles in it. So every time your rect is running and it's working. Yeah. So I think I'm going to do this in multiple parts because otherwise it's going to be very long. So this is part 4.1, and yeah, hope you like this video. If you do, please leave a like, comment or subscribe, and yeah, goodbye, I'll see you next time.